exercise 13.2 limits and derivatives. So we have completed the questions from 1 to 10. Now let us solve the 11th question and the first sub question. The first sub question is sin x into cos x. So we have to find the derivative of this function. That is, we have to find d by dx of f of x, which is also denoted as f dash of x. So this is the function, right? So let us label. Let f of x is equal to sin x into cos x. Now this is the function f of x. Now we have to find the derivative of this. To find derivative, we have to differentiate. So differentiate both sides with respect to x. We have d by dx of f of x is equal to d by dx of sin x into cos x. Now this implies d by dx of f of x is nothing but f dash of x. Derivative, right? Now d by dx of sin x into cos x. So this is function into function, product of two functions. So when you have product of two functions, from the algebra of derivatives, we have learned that d by dx of uv is equal to u into dv by dx plus v into du by dx. This is u and v. So we will write sin x into d by dx of cos x plus cos x into d by dx of sin x. Now this implies f dash of x is equal to sin x into derivative of cos x. So in the first principle also we have learned derivative of cos x. Derivative of cos x is minus sin x. So in the first principle we have calculated the derivative of cos x, right, which was minus sin x. Then plus cos x into derivative of sin x. Derivative of sin x is cos x. Now this implies f dash of x is equal to minus sin x into sin x is sin x the whole square plus cos x into cos x is cos x the whole square. So this implies f dash of x is equal to minus into sin x the whole square can be written as minus sin square x plus cos x the whole square is cos square x. You should not write cos x square. This is wrong. So you should write cos square x. So therefore the derivative of this function is cos square x minus sin square x. So this is the required derivative. So we completed the first sub question. Now the second sub question. Secant x. So we have to find f dash of x, that is d by dx of f of x. So let us label f of x here. So let f of x is equal to secant x. So here we know that secant x is also 1 by cos x, right? Reciprocal 1 by cos x. So we know the derivative of cos x, that is why we are writing in the form of 1 by cos x. Now we have to find f dash of x. For that we have to differentiate. Differentiate both sides with respect to x. We have d by dx of f of x is equal to d by dx of 1 by cos x. Now this implies d by dx of f of x is f dash of x, both are same, right? F dash of x is equal to d by dx of 1 by cos x. So here from the algebra of derivatives, we have to apply u by v, function by function, function by function. Here quotient of function, quotient of function. So we have to apply this formula. So you will get in the denominator cos x the whole square into cos x d by dx of 1 minus 1 into d by dx of cos x. Now this implies f dash of x is equal to cos x and derivative of 1, which is the derivative constant, so it is 0. So derivative of a constant value will be 0 minus 1 into d by dx of cos x. D by dx of cos x is minus sin x. So you will get minus sin x divided by cos x the whole square. Now this implies f dash of x is equal to cos x into 0 is 0. Minus times minus is plus, sin x divided by cos x the whole square can be written as cos square x. Now this implies f dash of x is equal to, so 0 plus sin x will be sin x by cos square x. Now this implies f dash of x is equal to, here we can simplify sin x into 1 cos x by 1 by cos x. So this is cos x into cos x is cos square x. Okay, we have written in as fraction into fraction. Now therefore f dash of x is equal to sin x by cos x is tan x and 1 by cos x is secant x. So this is the derivative of the function secant x. So now on you have to remember derivative of secant x is secant x into tan x. So hence we completed the second one. Now let us solve the third sub question, 5 secant x plus 4 cos x. So let us label, let f of x is equal to 5 secant x plus 4 cos x. Right, so we have to find f dash of x. So we will differentiate both sides with respect to x. We have d by dx of f of x is equal to d by dx of 5 secant x plus 4 cos x. Now this implies d by dx of f of x is nothing but f dash of x is equal to, now derivative of sum of two functions. Derivative of sum of two functions is equal to, so if you take this as u and v, so you will get du by dx plus dv by dx. Now this implies f dash of x is equal to, here it is d by dx of constant into a function, constant into a function. So we will take the constant outside and we will differentiate secant x. So secant x can be written as 1 by cos x plus, here also derivative of constant into function. So we will write constant and then we will write d by dx of cos x. Now this implies f dash of x is equal to 5 times derivative of 1 by cos x. Now we will apply u by v rule here because it is a quotient of function, u by v rule. So we will apply algebra of derivative. So you will get in the denominator cos x the whole square into cos x d by dx of 1 minus 1 into d by dx of cos x plus 4 times derivative of cos x. You can write this directly, minus sin x, which we proved using the first principle. So in the question, if they have mentioned using first principle, then you have to apply first principle and you have to solve. Now this implies f dash of x is equal to 5 times, in the denominator cos x the whole square can be written as cos square x, cos x, and derivative of constant 1 is 0, minus 1 into derivative of cos x is minus sin x, plus times minus is minus 4 sin x. So this implies f dash of x is equal to, let us multiply 5 inside, cos x into 0 is 0, so this term will get cancelled. Now minus into minus is plus 5 into sin x divided by cos square x minus 4 sin x. Now this implies f dash of x is equal to, here we can write 5 into 1 by cos x, one time we will take, another time we will include with sin x, and minus 4 sin x. So therefore f dash of x is equal to 5 into 1 by cos x is secant x, sin x by cos x is tan x, and minus 4 sin x. So this is the required derivative of the function 5 secant x plus 4 cos x. So we completed the third one.